The stress on the starboard cable is fluctuating rapidly.
We're seeing corresponding spikes near the rotor joint. Confirm the reading.
The digital twin confirms stress fractures on the starboard wing joint.
Acknowledged. Increasing buoyancy on line 3 by 5%.
The stress fracture here is significant.
Confirmed. Reading 4.2 millimeters on the caliper. We're clear on the left.
Okay, bring her down another foot. Watch the rear support.
Note the bent metal at the leading edge, along with the fatigue scars.
And the greenish patina suggests advanced oxidation.
Bring it down 20 centimeters, easy now. Copy that. Watching the clearance on the starboard side. Looks good, lock it down.
Check the alignment on that bend. We need to scrape this section thoroughly.
It's holding steady now. Let's get the treatment applied.
Apply 2 more degrees.
Reading stable now.
Alignment confirmed. Secure the brace.
The green jelly is mostly cleared.
Bringing the brace in now. Looks like the stress path is stabilizing.
Bring it down 50 millimeters. Reading confirmed, coming down slowly. Torque set on the nacelle brace.
All right, align the brace over the stress fracture.
Setting the torque now. We need to avoid that residue patch.
Right there, near the damaged linkage. Can you get a reading with the caliper?
Measuring now. The structural wear is significant.
The alignment is correcting slowly.
Confirmed, holding steady at 98% tolerance. Look at the deflection here on panel 7. It's critical. There. I see it. Grab the temporary support brace. Let's secure it now.
Look at the alignment data here. The stress levels are critical.
Agreed. The bending moment is significant. We should recommend immediate replacement.
Look at the extent of the pitting here, right near the connector.
Yes, the EDS confirms chloride presence in this specific area.
This white powder suggests extensive oxidation near the fatigue crack.
Noted. The structural wear is severe.
The corrosion here is worse than expected. The pitting goes deep, and the linkage near the actuator is definitely compromised.
The deformation here is significant.
And look at the corrosion pattern on this linkage. It's spreading rapidly.
Look at the extent of this pitting on the valve.
The stress fractures confirm the fatigue failure point.
We should isolate that section for further analysis.
The bend radius here is below tolerance. We need to document the corrosion at the apex. I have the measurements logged.
Careful on the left side.
It's secure. Hand me the torque wrench.
Secure the brace flush with the casing.
Stress levels are high at node 4. We need more support. Levels normalizing. Proceed to phase 2.
The corrosion here is significant. Record the depth.
Reading 0.05 millimeters on the scanner.
Torque is good on the tail stand.
That dent goes deeper than we thought.
Yeah. The corrosion around the rotor mount is also severe. We need to factor that into the repair timeline.
Lower the starboard actuator arm slowly.
Confirmed, moving to position.
We have green alignment on the main spar.
Okay, bring it left 2 centimeters. Easy now. Copy that. Moving left 2. Holding steady.
Look at that
Nice.
shine.
Yeah, that's
shine.
best restoration we've ever done. It's perfect.
Keep it steady on the starboard side. Watch the clearance.
Confirmed. Moving 5 clicks forward.
Ground, this is Osprey 6, requesting engine start confirmation.
Copy. 6. All systems showing green. You are clear.